Determine the Verdet constant using flint glass square. This is based on Faraday effect, and the formula for the Verdet constant is V is equal to phi by BL. Phi BL I will explain later on. So this is a lamp basically which produces the white light, and if you want to change the intensity of this lamp, you can change with the help of this one. Change the voltage, accordingly the intensity of lamp will change. So try to have a intensity of lamp in such a way so that heat producing is lesser, because this is otherwise also, because Verdet constant depends upon heat temperature also. So try to have a intensity so that we have a suitable result. This is a polarimeter from where you can we will try to fix the maximum intensity. This is also the one of the angles for showing the polarimeter. So it will polarize the light. Similarly, this is the basically electromagnet, and here you will try to put the sample. Whatever sample you want to study, that I will try to put here. This is a probe, I will explain later on. This is basically supply to the power supply to electromagnet. This is a sometime what happens, the overload is there, it blinks also, and then try to rotate the knobs to V and I to 0 and reach the press it reset button. So rotate both the nodes for V and I at the same time for changing the current, or you can say current supply to the electromagnet. So do it slowly, and you can move both together also, otherwise overloading is there. Now this is a basically probe for measuring the magnetic field. This is a probe. This is basically polarity. If you want to reverse the polarity, then you can exchange this red and black wires with each other. Accordingly, polarity will be reversed. You can reverse this probably from here also. But I have tried. I have given the reverse polarity from these two wires only, these 4 wires only. This is this instrument which digital Gauss meter, from where I have measured the magnetic field. So this the magnetic field is measured in kilo Gauss, and this is scale. Scale means whatever reading is there, you can multiply 1 if you select 1, and if you multiply by 10, then you have to select the scale accordingly. So this is the analyzer, from where I will put the intensity on the detector, whether maximum or minimum. I have chosen the maximum, but anything you can choose, either maximum or minimum. This is a photometer, or you can say lux meter also, that measures the output from the detector. This is a material, flint square glass, right? A square glass basically made of flint material, right? Whose Verdet constant I have to measure. This spelling mistake is there. This is Verdet constant. Now, this is a photometer. This is a complete setup for the measuring the Verdet constant. This is a photometer. This is a Gauss meter. This is a detector. This is an analyzer, and this is the material which whose Verdet constant I will try to measure. This is a flint glass material. This is a power supply to the lamp basically, and one is a power supply to electromagnet, this one, lower one, right? From where here I can give the particular current, or you can say which will produce a magnetic field, and accordingly we can measure that magnetic field on Gauss meter. So that is the polarity can be reversed if you want to reverse, and this is red and black, this wire can be interchanged. So that is the basic complete setup. And how we are measured now? Okay, first step is that step 2, set the polarization angle to that reading on photometer is maximum. Means basically photometer reading will be maximum on no current. So polarized angle we have to set in such a way so that reading on the photometer is maximum, right? At no current first of all. This is the video. This is a photometer where we will try to see where the maximum reading is there. Analyzer we will not put in this step, and we will remove the analyzer and only polarizer will be there at zero current. We will set the polarizer in such a way so that maximum intensity is there on the lux meter or photometer. Now rotate the analyzer. Now first we have put only polarizer. Now we will put the polarizer, fix it for maximum intensity, then put the analyzer also. And from analyzer also, the maximum intensity will fall upon the detector, and accordingly on the lux meter reading will be maximum, right? So I have written rotate the analyzer at angle so the reading on the photometer is maximum at no current. Change the current to 1 ampere and rotate the analyzer so the reading on the photometer maximum. Then 2 ampere on the electromagnet. 2 ampere is given. Then 3 ampere is given. 4 ampere is given. 5 ampere, whatever the current is available, you can give, right? Accordingly, you will see the magnetic field will be produced. You can see this is video. This is analyzer we are setting. So that the current on the reading on the photometer is maximum. So we will try to just such a way. We will try to find the analyzer angle such a way so that photometer reading is maximum. It will change. So we have to select the angle in such a way so that reading on the photometer is maximum. This is a table. How to do calculations. For 0 ampere, right, the angle of analyzer was 355, where the reading of the photometer was maximum. So naturally 0 current means geometric field. So length of material is same material we are using. So Verdet constant is phi. Phi means change in angle. Change in angle, how to calculate? Means angle of analyzer at 0 current is this one, 355, and for 6 ampere it is changed to 348. Accordingly, the shift angle is 7 degree. According this is radian, because I am measuring the reading in radian also. Formula is radian Tesla per meter. This is radian, this is Tesla, this is meter. So accordingly, these are the values. So 0.1222. So that is 0.1. This is the 0.1222, and 0.02. This is the length of the material, and 0.320 is basically the magnetic field. So accordingly, this is a reading 19.06. Similarly, for this 7 ampere, this is a reading, and now the 6 ampere again. This was 6 also. This was 6 also. But here polarity reversed. So accordingly, minus sign I was getting. So minus sign means basically because I need magnitude only for the Verdet constant. So accordingly there. So 7 ampere same value. So 4 values are there, and then I will try to take the average of these, and this is the answer. V is equal to 19.03 radian Tesla meter. Thank you.